So today we are going to talk about one of the very important frameworks which we have. If you guys are attending the sessions from SkillUpRight, so we had a discussion about one of the frameworks called LangChain in the earlier webinars. And today's webinar, we are going to focus on LangGraph. So LangGraph is again one of the packages coming in Python. It's a framework for creating the applications, or I can say the agentic AI applications, and making it more powerful. So we are going to understand first of all a bit of a theoretical part, and then we'll see few of the examples, and you can see that how nicely and quickly we can create a simple you can say chat bot or something like a simple chat machine, right? It's going to be an introductory session, so we'll not be creating very complex ones, but yes, you can actually create very complex agents as well using LangGraph. So LangGraph is an orchestration framework that enables you to build stateful, multi-step and event-driven workflows using large language models. It is ideal for designing both single agent and multi-agent agentic AI applications. Think of LangGraph as a flowchart engine for LLMs. You define the steps, that is also known as nodes, how they are connected, that is known as edges, and the logic that governs the transitions. LangGraph takes care of state management, conditional branching, looping, pause/resuming, and fault recovery. These are the features which are essential for building robust production grade AI systems. Now you must have heard about LangChain as well. So LangChain is good for simple and linear workflows. And if you want to make more complex and non-linear workflows, in that case, you can think of using LangGraph. So these are the different section of your graphs. Think of a graph like a metro map, where the map itself is the graph. It shows every place you could go. Each station is a node, a step where something happens. You board, switch lines, or exit. Each track between stations is an edge. It tells you where you can go next. You travel from station to station along the tracks until you reach your destination. That's exactly how AI workflow runs in LangGraph. It moves from one node to next node along the edges. So let's go ahead and let's try to see that with certain examples. So I'll be opening my Jupyter notebook and we'll try to create one small calculation. Although I'm not going to use LLM as of now, right? We'll enable the LLM in some time, but as of now we are going ahead and creating a basic flow using LangGraph where no LLM is there. You have to install one package called LangGraph, pip install LangGraph, right? So I already have it in my machine, so I'm not doing it. But to enable that in your machines, you have to go ahead and you have to install this particular package. I have to import these modules in my current instance of Jupyter Notebook. So here I'll do that. So LangGraph dot graph import state graph start end and state graph, right? So these are the three things which I want to import. As of now, what I'm going to create is I will be creating a simple calculator which calculates your, let's say BMI, right? So let's go ahead and let's call typing as well. Import type dictionary. So these are the two modules I wanted to import. Now what I'm going to do next is I'll be going ahead and creating one state. Now what is a state? Let's try to understand that. So think of state as a case file that travels with your workflow. Every step, that is node, reads what's already in the file, adds / updates a few fields and passes it on. It's like in a kitchen, the order chit that moves from counter to counter. In support, the ticket with user issue, priority, owner and comments. In delivery, the parcel label plus a log of where it's been. That's moving every updated bundle of info. That is state. State is something like the, what do you say, the current state of your graph, right? So suppose you are creating one agentic AI application. So at this point of time, what is the current value for all the different parameters which we want to move ahead? What lives inside the state? Whatever your next step need to know, typically user context, prompts, messages, selected options, intermediate results, retrieved documents, tool outputs, model answers, control flags like need, human or not, low confidence, high confidence, next step, bookkeeping, who's assigned, timestamp, attempt counts, SLA timer, and so on. States are shared and mutable, right? So that is what we are now going to create here. I am going to create a BMI calculator which will calculate your BMI, and based on that I want to categorize as well whether you are overweight or lightweight or maybe underweight or maybe average, right? Something like that. So I'll be creating one class that is BMI state, which is going to inherit from the type dictionary. So it's an object oriented programming language. So I'm taking my type dictionary as the parent class, and BMI state is inheriting from the type dictionary. Underscore kg is my float. Height underscore meter is in my float as well. BMI also will be a float. And finally category, which will be a string, right? So this is the state which I am defining, where user will pass the weight and the height. Based on the weight and the height, the BMI will be calculated. And once the BMI will be calculated, yeah, you will get this recordings in the YouTube. Absolutely. So once the BMI will be calculated, I will be calculating the category, right? So that is the requirement we have. So let's go ahead and let's do that. So I imported the modules and I created the state. Now I am going to create one function. What I want to do, I want to create a LangGraph graph where I will have the nodes, I will have the edges, and the flow will happen, right? So basically when we are creating a LangGraph, right, the nodes and all, nodes are basically nothing but Python function. So here I am creating my first node, which is going to calculate the BMI of the person. So I'll be creating one function, calculate underscore BMI, where state will be the input for every node, right? When we are creating a LangGraph, every node gets the state. What is the state? This BMI is the state. And what output it will return? It will return the same state with the updated value, right? So input is a state, which is this state, and output will be also the same state, which will be giving me some updated information. In this scenario, height will be given as an input, weight will be given as an input, and what output you are going to get? You are going to get the output as height, weight, and BMI. Right? So BMI will be your output in this particular scenario. So let's call the weight. That is your state G. So basically this is the weight which I am calling state's weight. and I'm storing in the weight variable. Same way I'll have the height also, state of height in meter, and I'm storing that in the height variable. And then I want to calculate the BMI, that is weight divided by height square, right? Divided by height square. And this particular BMI which I got, I will be updating that in my BMI variable in the state. Right? This BMI which I have calculated, I am storing that in the state's BMI. And that's it. I will be returning the state. So that is what my first node is. Calculating the BMI. Input will be height and weight. Output will be again BMI state that will have height, weight and BMI. That is what this node is doing. Now I am creating another node. Based on the BMI value, I want to segregate my maybe the individual, right? And I will categorize that. So now category will be the output coming in. Again, I am creating one more function, label BMI. State is my BMI state, and my output will be also BMI state, right? BMI, I already have it. I am calling that from the state. This BMI which I have called, I will be using this for segregating my end user. If the BMI is less than 18, then I have a state of category. What category I want to assign? I want to assign underweight. Right. If the BMI value is more than 18, or I can say more than equal to 18, and BMI value is less than equal to 25, then I want my state's category value to be normal. If the BMI is more than 25 and the BMI is less than 30, in that case I want my state to be overweight, else obese, else my state to be obese. Right. So that is my second function, and I will be returning my state. So that is what we got. So user will be passing weight and height. Here in this particular node, my BMI will be getting calculated, and in this particular node, my category will be calculated based on the BMI. So how my workflow will look like, right? How my graph will look like. Let's try to understand that. So my graph will be something like this. I have a start, then I am calculating the BMI, then I am calculating the label of a BMI, and then I am ending. Right? This is my graph. User will pass the height and weight. BMI will be calculated here. Using BMI, obese or categorize, right? It will categorize that and output will be coming in. So this is what we are creating. We already created these nodes. Now we have to connect these nodes, right? We have to generate these graph. So let's do that. So now here in this step, we are going to generate the graph. So graph is equal to state graph, where BMI state will be my state which will be taken in every nodes of your graph. Graph dot add node. I want to add calculate BMI, and I will be calling that function calculate BMI. I will be adding another node, graph dot add node. The next node is label BMI, and I am calling this label BMI function as well. So here the nodes are created. Now I want to define the edges, right? If you go back to the documentation here. So what is a node? A node is one step in a process. It takes what we know so far. We know height and weight, right? So it will take height and weight, does a small job, adds the result. It will do a small job calculating the BMI and add the result. What is an edge? An edge is a connection from one node to the next node, right? So we have to generate the connection. How the connection will be? Calculate BMI to label BMI, and from starting, right? Start, calculate BMI, label BMI, end. And what is this start and end? This is the start and end, right? So that is what now we will call. So I want to have a graph dot add edge, starting from start. Where it is going? It is going to calculate BMI. After that, graph dot add edge. Now from where to where it will go? From calculate BMI to label BMI. To label BMI. And what is the third connection? The third connection is add edge. I want to go from label BMI to the end. That is what we are expecting. Start to calculate BMI to label BMI to end. So here it is, start to calculate BMI, calculate to label to end. And I will compile this graph, right? I'll give a variable name called workflow, and I will compile this graph dot compile, and I will call my workflow to see how the workflow looks like. So here you can see that this is my workflow coming in, right? Where you can see we have calculate BMI and label BMI. So my entire graph is ready. Now let's take one input and let's see what's happening, right? What will be my initial state? My initial state will be weight and height only. BMI will be calculated by the graph, and category will also be calculated by the graph only. So I will be passing my initial state. And that is nothing but weight in kg and height in meters, right? So weight in kg, let's say 80, and height in meters, let's say maybe 1.8, right? Workflow dot invoke. I want to invoke my initial state. And once I do that, you can see that I am getting the BMI of that person with the weight of 80 and height of 1.8 and the category of that person, right? You can very well change this. Let's say the weight is 83 and height is, let's say, 1.73. So here you can see that it is coming out to be overweight, right? So this is the entire flow which we have created. Here I did not use any large language models or something, but it is pretty much like a flow which we have created. Based on this line, what we are going to do, we are going to use now the large language model. I will be using the OpenAI API, right? So I'll go to platform OpenAI, and I will get the API first, API key, and I'll be using that API key in my workflow to ask normal questions from the chat model. So you can also have this API key. You can recharge your this platform account, and you can do that. So here I am passing test as the key name, and this is my key which I am going to use, right? I'll save this key in the folder where I am running all these things. So let me go and do that. Just give me a second. Yeah. Here is the environment file, and in this environment file, which is looking like this, I'll be changing my key to the new key because we just created a new key, right? This is my new key which we have put it. Now we'll go back to your Jupyter notebook and we'll create a small graph where we will be using this chat model. Okay, so here I am now calling OpenAI chat model. Now what we want is, we want a simple thing, right? We don't want to make anything complex as of now. What we want is, we'll have a start, we'll have a chat model, and we'll have an end, right? That is what we want, where user will ask a question and your chat model will respond based on that. Okay, so let's do that. So I'll be again importing. So already I imported this above, but I am again importing it so that you can very well copy paste and run your flow. So here I have to import these two things. Apart from that, I need to call LangChain chat OpenAI because I have to call my chat model. So from LangChain dot, or I can say LangChain OpenAI import chat OpenAI. Okay. And also I want to load my environment file. So .env import load.env, which is helping me to load my environment file where my API key is present. So I'll be loading my environment file and I will be loading my chat model as well. Let's call this model name as model, right? So here I have loaded the environment file and also I gave this chat OpenAI as a name model. Now I will be creating a state, right? State is the first thing which we have to develop. So class LLM state, where I am passing this type dictionary and I am asking question, right? Which is str, and your answer will be coming from the model. That is also str, right? So this is my state. User will pass the question and machine will respond, and that will be stored in the answer. Okay. Now I will be creating the function, the node basically, LLM chat, and here I will be having a state as an input, that is LLM state, and my output will also be LLM state only. Question is equal to state of question. And based on this question which user asked, I will be creating a prompt. What is the prompt? The prompt is answer the following question. That is nothing but my question variable, which is coming from the above line. Answer is equal to model.invoke. Model is nothing but this chat model. So I'm invoking that chat model. I'll be passing the prompt and dot content. And then I will be storing the answer coming from the model in the answer variable in your state. And then I will be returning the state. That's it. So this is my node which we created. And now it's time for us to create the graph. Graph is equal to state graph of LLM state. I have to pass as an input. Graph dot add node. My node is nothing but your LLM LLM underscore chat, LLM chat, right? That is my node. And then I will be having the edges. My edges will be graph dot add edge, start LLM chat, graph dot add edge, LLM chat to end, right? That is my graph. Workflow is equal to graph dot compile, and then I can check my workflow how it looks like. Here you can see that some error coming in. This will be a start. So here you can see that my chat model is coming in, right? Now let's pass the initial state. My initial state is a question, right? So let's pass a initial state, which is nothing but a question coming from the user. That is, who is the Prime Minister of India? And this I will be passing in the workflow dot invoke, and I will be passing this initial state, and when I run this, you can see that I am getting the response coming from your model, right? And that is basically I am using my LLM. Now here I can have multiple chains as well, right? As of now it was single LLM. I can have multiple chains as well, as in I want the outcome of one LLM as the input of another LLM, right? So that type of thing also we can do, and we can make it more powerful. We can have a chains as well. We can divert as well based on the condition, right? For example, there is a request coming from HR, so it will go to the HR chatbot. If there is a response coming from finance, it will go to the finance chatbot, and so on. So we can actually branch it as well using conditional edges. Here you can see that graph dot add. Here you can see conditional edges, right? So based on the conditional edges, you can divert the things also. Let me create one more chatbot where I will have two chatbots in a same line, right? For example, let's say I want to write a blog, right? I have a start. I have a maybe create the blog title, and then I will be asking for the blog content, and then end, right? Something like that. So what we will be doing, we'll be creating another sequential type of graph where I will be asking my user to asking the chatbot to basically generate the title for my blog, and then I want to generate the outline, or I can say content for my blog, right? So let's do that. Okay, so let me create that. So first of all, again, I have to import all these modules, right? After that, I will be going ahead and I will be generating the chat model, that is chat OpenAI. Okay. Now let's go ahead and let's create a. The very first thing which we have to create is what? It's a state, right? So blog state. It's a type dictionary. Again, I will be having what? Let's say user will ask, user will give the topic, right? So user will give the topic, on which topic he wants the blog, right? Once that is done, I want to give a nice title. I want the title from the ChatGPT, right? So title will be coming from ChatGPT, and then I will be getting the content. Content again will be coming from ChatGPT, right? So that is my state which I have defined. So let's create the first node, that is create title. Right? My input will be state, that is block state, and my output will also be block state. I will be getting the topic. I will be getting the topic from the user. So that is coming in that is present in the state. So I'm storing that. And then I'm generating a prompt. I'm generating a prompt. What is a prompt? Generate the catchy title and SEO friendly title for the given topic. And topic will be coming from the topic variable. That is the prompt which we are passing. And here I'll have the title is equal to model dot invoke. I'll be passing my prompt dot content, right? And then whatever title I will get, I will store that in my state, right? And I will return the state. That's it. So that is my first node. Now, based on this title which I got, I want to create the content, right? So I will be creating a second node now. So def create content, that is block state, and output will also be a block state. Title will be the input. Which is coming from your state, right? And based on this title, I want to go ahead and I want to generate the content. So I'll be having a prompt. Write a detailed blog on the title, right? Make it 100 words blog, right? I'm not writing more, so 100 words blog. Based on that, use the SEO keywords for better reach, right? So that is my prompt which we have given. Content is equal to model dot invoke prompt dot content. State is my content. State is all coming from here, right? So content is one of the variables where it will be storing the content. And then I will be returning the state. That is my second node. And now it's time for me to create the graph, right? Graph is equal to state graph, where I have the block state. I'll add the nodes where I have what? Create title. What function we gave? Create title. So we'll pass that function. Create title. Second node is graph dot add node. I have the create content. The function name is create content. Now I will be adding the edges, right? So graph dot add edges, starting with start, and create title, right? Then graph dot add edge. Now from where to where? From create title to create content, right? And then graph dot add edge from create content to end, right? Then I'll have the workflow where I'll be having graph dot invoke, sorry, compile, right? And I'll check my workflow. So here it's still executing. Let's see what happens. There can be some typos, so because of that error may come in. We got some timeout error. Let me rerun this. Already getting some error here, timeout error. Give me a second. I'll just check. I have another code. If that runs, I'll show you that. Yeah, I think that is running fine. Just give me a second. I'll just check. Let me show you this code now. So basically the same code we have written. So we had all the input. We are giving the title and we are asking to generate the outline, right? And from the outline, I am asking to generate the content. So here is the graph we are generating. So start, create outline, create content, and end. Here is the topic. Initial state, title equal to AI in India. So it is, you can see, generating the entire details for you. Title is AI in India. So it will generate first the outline. So this is the title. So you can fetch it out here as well. Here is the title. Here is the outline. And here is, you can see the content, right? So this way it is generating the entire flow for me. So it's a two-step process we have, right? So this way you can actually create a very powerful chatbots, which can make it, what do you say, make your development very simple. Did we use the API? Yes, I use the API key from OpenAI only. You can use any other also, Claude, Anthropic, or any other thing. Is there a way to use have this created automatically without writing graph steps in code? That is how it works, right? That is how this works. In LangGraph, this is what the step which you have to perform. Okay. Just give me a second. I'll see one more thing I can explain. Just be on hold. Okay, let me show you one more thing. Let's create a basic bot. Now what we'll do is we'll add certain modules, right? So from LangGraph dot graph, import state graph, start, end. From typing, import type dictionary. From lang chain underscore core, import messages, import human message and base message. And from LangGraph, sorry, from LangChain OpenAI, import chat OpenAI. Right? There are different type of messages are available. Right? We have a human message which is from human coming in. There is a system message which is defining the goal of the chatbot, and there is a AI message which is defining the goal of your this thing AI. Same way we have base message as well. Base message is basically nothing but it's like a parent class, right? Human message, AI message, and your system message all coming from the base message only. So that is what we imported. Now, also one more thing I will import from LangGraph dot graph dot message, import add message, right? So that is one more thing I have to import. Once that is done, I'll be calling my LLM, that is chat OpenAI. This add message is basically nothing but suppose user is asking something, right? So based on that, I want to go ahead and I want to save that message for future reference because I need a memory as well. Your large language models are all stateless where no memory is there. So I want the memory. So that's why I need to add those messages. Type dictionary messages is equal to annotated. I think I missed that part. Type dictionary, comma annotated. List of base messages and comma add messages, right? So that is my state. I have to pass it with the colon sign. So that is my state, right? I will have a base message and it's a list and new messages will keep added on that particular list for have the memory, right? Now I'll create a node that is chat node where state will be my input. That is nothing but your chat state. Messages is equal to state of message. Response is equal to LLM dot invoke messages, and then I will be returning the messages. That is nothing but response in a list because I want to append that list into my state, right? So that is my chat node, and now we'll create a graph, state graph chat state graph dot add node chat node and then graph dot add edge start chat node graph dot add edge chat node end. Chatbot is equal to graph dot compile. So this is my chatbot graph coming in. Let's pass the message. Initial state where I have a messages. A human message. For example, content is equal to what is the capital of Gujarat, right? And then chatbot dot invoke the initial state, right? So when I run this, you can see a lot of content coming in. It was the human message and this is the AI message. My interest is to pick up the last message, that is the AI message. So I'll be passing -1, the reverse index dot content. Right? If I do only reverse index, I'll be getting the entire AI message. Sorry, initial stage of messages, my bad. Messages. I'll be getting the AI message, but in the AI message also I am interested in the content, right? So I'll be passing dot content. So this is going to give me the answer. Okay. Now in this, the next thing which we can add is persistence. Persistence is basically nothing but where I want it to be, like I want my chat memory to be stored in either in the RAM memory or I can store that in a database as well. Right? So all those things, again, bit of advanced concept, but the idea is that in the first session, I just wanted to discuss about the brief understanding of LangGraph, and you can see that it's like pretty much simple to write the code. You just have to create the state. You have to create the nodes, connect the nodes with the edges, and that's it. As of now, we just created the simple graphs, which is like a linear, but we can create some of the interesting complex graphs as well. Let me show you some of the graphs which I have created, which we are going to see maybe in the future sessions. Just give me a sec, I'll save it. So this is one of the graphs for invoice management system which I created. Here you can see, right? So here you can see that we have this entire invoice management system graph using LangGraph. So what is going on here? User will pass one prompt, right? Now this particular graph does two things. One is the RAG application. User will ask any question about financing. It will go and hit the RAG application and it will hit the documents of the company, and based on that it will respond. That is one part of this graph. Second part is user will generate one invoice, or user will ask machine to generate one invoice. So here is the create option. User says that I have this invoice, I want you to create that. Create means insert that in the database, right? So it will first validate. What type of validation we are doing here? Whether the purchase order number, PO order number is there or not. If it is not there, that is true. It will email that your PO is missing. And if it is there, in that case, it will ask human for approval. And once it is approved, it will write it in the database. Same way for delete as well. It is deleting, validated, delete approval summary, and then it will delete the invoice. Same for the second delete. So basically we had two tables. One is the invoice table. So it is deleting the invoices, and second is the PO table, which is helping me to delete the POs, right? So that is the deletion part. Then we have the read part. Basically, I want to know what all invoices are there, all the information from the table. So this read chain will be going ahead and doing it for me. Suppose I am saying that give me the invoice number 123. So it will give you the outcome of all the invoice details of invoice number 123 and so on and so forth. So we can do a basic analytics in this particular chain. And lastly, we have the update as well. I want to update my invoice number. First of all, once user will ask that you want to update, let's say user is trying to update the PO number. So it will just check whether PO number is there or not. If it is not there, it will send an email that you are making the update of PO number. That PO number does not exist. If everything is fine, it will just validate everything is fine, take the approval and update the records, right? So that is again one of the graphs which I have created. Same way you can create some of the complex graphs as well. In today's session, it's more like understanding what LangGraph is and how it works. I gave you 2-3 examples, which will be good to go with to at least create the basic type of flows, right? Maybe in the next session, which we are planning in the next month, at that time we'll see more complex graphs as well. So that is what I wanted to cover. Any doubts you guys have, you can ask now. And I'll share this code with the support team and they will forward it to you. Any queries, any doubts, you can ask. You can put your questions on the chat. Any doubts you have? Alright, so no questions coming in. I hope you got something new from this session. We'll see you in the next session. Till then, take care, guys. Have a nice day.